Hello, good morning to everyone, and welcome to the DestinEStreamer in Action webinar about unlocking the Earth observation and climate data for users. We have just a couple of minutes for everybody to connect, but please don't hesitate to use the chat, write your questions in the Q&A section. Another thing to mention is that we are recording this session, this webinar, so that means that after the webinar we'll be also able to share the recording, and also we will share with you a feedback form where you'll be able to actually share your experience of this webinar, maybe some suggestions for improvements, and your general feedback. Okay, some people already connected. This Barbara Scarda from DestinE Platform, from Circle, sorry, who present DestinE Platform. I would like to pass the floor to you for the brief introduction to the DestinE Platform.
Good morning, everyone. Thanks to Valeria for the introduction, and many thanks to all of you for joining this DestinE Platform webinar. My name is Barbara Scarda and I work for Circle. We are under a contract with ESA to implement and operate the DestinE Platform together with an industrial consortium. Now, before handing over to the colleagues from partner GeoVille, I'll take just a few minutes to introduce the DestinE Platform. So the platform is one of the three components of the Destination Earth initiative of the European Commission. It's an ecosystem of services designed to tackle global challenges through cutting-edge technologies and to provide seamless access to this ecosystem of services. Let's go quickly through the user journey on the platform, as each step is interconnected to ensure a smooth user experience. So I'll mention registration, access upgrade, the service registry, user support, and the public roadmap. So the first step into the ecosystem is the registration process. Now, I imagine most of you are already registered users on the platform. By the way, we currently have more than 4,600 registered users as of today, and growing. Now, registration is really a standard process, so I will not get into details here. However, I just wanted to point out that it is important to fill in the user profile field by selecting your applicable category if at a later stage you wish to apply for upgraded access. And you can do this during registration or later from your user profile. Now, a few words about what upgraded access means. All registered users on the platform get basic access to a selected list of services. However, if you want to access services that allow downloading, services like DestinEStreamer that allow downloading of what are defined as DestinE primary and altered data, you need to apply for upgraded access. And here you find the definitions for clarity. DestinE primary data refers to data sets from the DestinE digital twins originating from ECNWF Euro HPC digital twin engine, whilst altered data means data derived from primary data that could be used to reconstruct the original primary data themselves. So if you wish to upgrade your access, you can request it from your user profile after logging in, and there is a dedicated section for that. Moving on to the service registry, you can access it by clicking on Services on the navigation menu of the DestinE Platform web portal. This is where you find all the services available on the platform. Right now, we have 28 services. You can easily filter them by category. For example, here's a list of the main categories: visualization or data access management, like DestinEStreamer, data analysis and modeling, or user workflow for development and processing environments. So how do we support our users? There are several ways to get help. You can check the support section for reference, where you find the FAQs, really handy if you're looking for quick answers, or the services documentation, or you may wish to get in touch with us directly by the service desk using the Contact Us form, or you may wish to visit our DestinE Platform Learning Hub, also linked from the support section. So the Learning Hub collects a series of educational material that includes various resources and documents to improve your knowledge, demonstrators, and also under training, the services video tutorial. And in particular, you will find 2 video tutorials for DestinEStreamer, a step-by-step guide, and a use case tutorial as well. And finally, a mention of the public roadmap, which you'll also find under support. You will find here a list of recently released features, upcoming functionalities, and most importantly, ideas for improvements suggested by the user community. This is part of our effort to stay transparent and make sure the DestinE platform evolves based on real user input. So what can you do as a user inside our community? You can engage with the platform by contributing actively with our public roadmap, which I just mentioned, participating in events like this one, sharing your feedback from the Contact Us form, using the Learning Hub and its resources to deepen your expertise, following us on LinkedIn for the latest news, what to expect for the DestinE future. We will keep adding new services and new data sets with more and more innovative features and capabilities to further develop the ecosystem. So that wraps it up in hopefully around 5 minutes. If you have any questions, feel free to ask now in the chat or get in touch later by the Contact Us form. And now I'll hand it over to GeoVille, to Wolfgang Kapferer. Thank you.
Okay, so thank you very much, Barbara. I hope you can hear me. Great, and I hope you can see my slides. Great. So welcome to DestinEStreamer. Now, what is DestinEStreamer? What is the vision behind, and what is the goal we want to achieve with that service? So the vision behind DestinEStreamer is that the amount of data from Earth observation, from climate science, is really growing exponentially. And this is, of course, a problem when it comes to usage, when it comes to data dissemination. So data abundance is really, at the moment, outpacing our ability to extract insight, to extract really the value of the data. Here's just one example where you can see the explosion in the future when we think about the Copernicus missions, where we have hundreds of petabytes in the future. And this comes, of course, with a lot of costs when it comes to hosting and disseminating data. But this is just one side of the problem. The other side of the problem is that all those nowadays data dissemination systems, they will reduce the effectiveness of the data in the future, because pipelines for machine learning, for AI algorithms are really starving in the future, because data can't be shifted to the computational resources as fast as needed. And we do lack in the future, of course, of the capability of edge devices if we don't think about how we can bring the data to the users and how we can store the data in the platforms more efficiently, and how to face them then to HPC facilities, or even to your devices, to your workstations, which you use to deal with the data. So the vision is now that we try with DestinEStreamer to solve a couple of these problems, and the basic technology behind comes from the video streaming market. So we are really inspired by the so-called OTT. OTT stands for over-the-top streaming. These are the big streamers like Netflix, Amazon Prime, Disney Plus, you name it. And we adapted their parts of their technology for Earth observation and for climate data to be capable to compress the very high resolution images, the very long time series, and the very high value resolutions in those data sets. We have for that a very high compression with an excellent quality, which I'll show you later on. And this, of course, lowers dramatically the costs and enables therefore deeper insight. One thing which comes along is not only the factor of cost, it's the factor of speed. So you can ingest the data much faster in your pipeline. You can scroll through time and space much faster. And this gives you a much better user experience and uses, of course, then the costs at your side when you are using the climate data and or Earth observation data. So when it comes to DestinEStreamer, in the DestinE platform, we offer you access to climate data like ERA5 to the digital twin data. And in the next release, which should come in a couple of days, we already have Sentinel-3 data, and we will provide you full Sentinel-2 data in a couple of days as well in the DestinEStreamer in the platform. We reduced the amount of data compared to the already compressed data, so already compressed ZAR files or already compressed gridded data by a factor of 10 to 40, which is quite a lot. It's a huge impact. But we have a service which really offers you the quality you need, because the quality, it's a lossless compression. It's not a lossless, sorry, it's a lossy compression, but the loss is very low and under full control. It's typically below 0.05%. I will come later on to a precise description on the quality. Now here you see on the slide just one example. You see an original zoom in on the ERA5 data set, the long wave radiation flux into South America. And you see the same from the DestinEStreamer, there the data is compressed by a factor of 30, by a factor higher than 30. And we have an average quality assessment of 0.90. I will come in a couple of slides to what the structural, spectral structural index measure means in detail. Now, here we are ensuring the quality. That's of course the the most important thing for you as a user. So you want to have access, fast access to data. You want to have the data very fast in your process chains. But of course, you want to have the data in the best quality. And this is our job, to provide you a service where we can offer you compressed data in a very, very good quality. To do so, there are different quality measures around. And together with ESA, we had a very close investigation into the quality imprints of the lossy compression of the DestinEStreamer when it comes to Earth observation data, when it comes to climate data. And here's just one metric I want to highlight to you, because that metric you will find within the platform describing the quality assessment of our compressed data sets. That's the so-called Structural Similarity Index, SSIM, which does not only measure the difference between some, let's say, statistics. It also measures the quality of artifacts you introduce in the structure of the data. So just one very small example. For an example, you see down there, that's the textbook example for measuring the quality of compressed data when it comes to raster data or image data. So here we have an original image. If you put a little bit of noise on it, or you put just a constant plus in the same amount on the image, then a root mean square would give you no difference. So it would be always 0.04 as in that example. So this would not, but you of course would agree that the image with noise is a much less useful image. And if you see the SSIM, so the Structural Similarity Index, is in the case where you introduce noise, it's in a value about 0.15. And if you just put a constant shift, it's 0.85. And this set means that a structural index in the range of -1, that's the total opposite, so the worst quality you have, +1, it's identical by bit value. And we have quality assessments, everything below 0.9, even 0.95, even 0.99 in SSIM, which is by far enough to have all the services runnable on the DestinEStreamer without changing any of your results compared as if you would use the original data. So how can you use then the DestinEStreamer? How can you utilize it? There are different vectors. First, I want to describe it a little bit. Later on, I will show it in the platform to you. So basically, we have a compressor packager, which takes AO and climate data and converts it into this format. Then we have a service layer where you can extract metadata by an API. So you get information with what data is there. you can get information on, if you think about, for an example, on Earth observation data, what is the cloudiness of a Sentinel-2 scene, or you get information about which timestamp, if you think on the climate data, is at the frame in your stream. Then you can convert, we have solutions that convert it at ad hoc cubes, so you can load it into your Python memory, you can load it into your Insula Jupyter Hub environment, and you can convert it to standard formats. So it will decompress it to, for an example, in a GeoTIFF when you think on Earth observation data, or into an you can put it into a TSAR representation for further investigations if you collect a subset and prepare the data for your further analysis. So there are many vectors to interact with the compressed data. You will not have interaction with the compressed data. We have a service layer above which should ease the usage as much as possible. And of course, you can connect it then directly to your algorithms. So suppose you have a TensorFlow or a PyTorch environment, and you want to bring the data into your training or inference. We have examples for that as well. Now, the service manages, as said, the metadata, the data, of course, itself, storage and access to data behind the scenes. We provide you conversion libraries, modules, and we provide you a web application. And this is very important. The web application and interface, very intuitive, where you can have a first look at the data and play around with the data, and maybe get some ideas how you could use the data. So, synergies is very important for us. It's one solution in the DestinE platform, but we have the same solution around at ESA, for example, in the Dunia project. That's a project where we offer Copernicus data for Africa for low bandwidth. Compression is there, of course, very important and key. And in other projects like Smart Connect, another ESA project in cybersecurity, where we can transmit Earth observation big data over very limited bandwidth, like SATCOM bandwidth, to bring the data really to very remote regions, even regions without no terrestrial internet connectivity. How can you access now the service in the platform? So before I have spoken a little bit about the service architecture and the layers in between our service layer for the users. Now we have Python modules, which you find in the documentation part in the Insula Hub. We have scripts there, example scripts I will show you later on. We have an interactive viewer, as said, and on top of it, we have a WebAssembly module landscape or architecture, and this is a quite interesting solution which gives you the capability to ingest climate data, Earth observation data into your browser and to do calculations, predefined calculations, which we inserted. But later on, we will enhance the service that you can really use via the WebAssembly module, the data in your browser, or then you pipe it into your machine for further analysis in a closed environment, meaning that's a closed memory environment, which basically enables you really to get the data from the platform to the edge in a very seamless, in a very, very fast way. We are very proud, in addition, that our solution does really work on mobile devices as well. This is quite natural to the solution. Why? Because we have a special focus on video over OTT streaming technologies, and they are especially made for mobile devices, because you want to stream, for example, your Netflix movie on your mobile, on your tablet. And this the same technology is used here in the DestinEStreamer. So you can stream the data on your mobile, and it will give you really a fast and a very intuitive access to climate data for first glance, for first inspections, and of course for Earth observation data as well. Now, I will show you later on some examples in the platform. Maybe I skipped that due to the time. And for accessing now, I think I can switch to my browser. So I will Okay, I will stop this sharing and skip to the browser. Okay, here we are. Do you see my browser environment? Yes? Okay, great. Good. So when you go into the platform, as you know, you have here the services. And when you click on the services, you will find us called DestinEStreamer. And this is the entry page, the landing page for the DestinEStreamer, which gives you a little bit of an overview for the DestinEStreamer, what we have. I have here, we are located GeoVille in Austria, in Innsbruck, and my browser here is now switching to German, so but you will find it in English or in your language. And we have here the documentation. So when you click here on documentation, you will be routed to the documentation where you have an introduction to the service, where you have an introduction to how you can use the service within the platform, introduction into our web application, and last but not least, an introduction in our API, so you can have a direct API Swagger interface as well, and you can access, of course, then the data via API. And we typically encourage you to use it within the Insula Hub because that works quite natural for typical machine learning Python applications. Now, let's go to the service itself. So this is the starting page of the service, the web application in the DestinE platform. And first of all, you have a map, and in that map, you have the possibility now to have a first look at some climate data sets and Earth observation data sets as said before. Well, after you have the possibility to select the data stream. At the moment, we have the ERA 5 service air temperature. As an example, you have a legend here, and you can now click play, and what you see now is starting from the year 1940, and on a daily basis, the temperature of the surface air temperature, that's the 2 meter above surface temperature. And you can fast forward here. So I can jump to the year 2002, and you see how fast that works. So this is a very nice thing to get the first glance into the data. As you see, as time goes by, and this is not a good sign, temperature rises, a sign of our climate change problem. And but in the platform, you have now very fast access, visual access to the data. So this is the first thing which is quite interesting and quite nice. You can, of course, minimize it, and you can do the same on your mobile. So you can use your mobile if you want now and play around with it. You have here some controls for the visualization. So for an example, the opacity, here you have a base map with the countries of the world. You can have here a little bit handle of opacity. You can, of course, zoom in. Another thing is you can have switching on and off the spatial interpolation. You know here that's the original data and the pixel resolution. You can have here a smoother representation by interpolation in space. Then we can, of course, have a look into another data set. Let's go for the mean surface temperature, for an example. That's the digital twin now. And now we are starting in the year 2020. And again, I press the play button, and then we zoom a little bit where we have, for an example, here the Gulf Stream. And I just go a little bit back and press play. So, and then you see you can really here have a look into the digital twins, into and how these data sets evolve. So we can have a look into the future in the year 2028, for an example, into the summer. And here you see, for an example, then the distribution of the sea surface temperature on the surface. Okay, so this is for selecting the climate data sets. As I said, we have Earth observation data sets as well. And I can click here on data sets. And for an example, here I can have a look at Sentinel-3 data. So Sentinel-C data, we have composites, continental composites of the NDVI. And again, you can press the play button and you see how the NDVI changes over time. What is the NDVI? That's a vegetation index obtained via the Sentinel-3 satellite. And it gives you a measure about the chlorophyll on the surface, in the plants on the surface of Earth. And it gives you an indicator about how much things grow and what is the health state of them. The, let's say, transparent region, they belong to cloudy regions. So in the winter time, of course, you have a lot of clouds here in Europe. But if you, for example, if you go a little bit faster, you see quite nice. In August, you have a height, so it's really the height in the NDVI. And then when it comes to winter, then of course the NDVI lowers because, as we know, the changing the time changes the NDVI. You have the possibility to switch here, for an example, to other continents. And one thing which is maybe something it's not so easy to find, if you are interested in Australia for the data, you can go there, check it, and then we have the same, and you would see the opposite behavior, and you would see then in the winter that there, of course, you have the maximum in the NDVI. So this is quite nice if you are interested in Sentinel-C and Sentinel-3 NDVI. I will show you later on the same for the Sentinel-2 data, which is quite has of course a much higher resolution. Now let's switch back to the climate data. I told you before that we have a capability of do some basic calculations, and there are two vectors now, and I want to show you the vector number one. That's the user-friendly vector, and that's our so-called Stat-on-Edge solution, and this is the edge computing solution. And for an example, I have selected here the ERA5 data set, as you see here down there. And now I can click on a country, and let's have a look. For an example, let's click on Italy, and then we can use Stat-on-Edge to calculate some statistical metrics for that climate data for that region. So let's say here are some predefined examples. And let's have one example. So you are interested, for an example, for the air temperature daily maximum in the August 23. So you would, it just predefines what is filled in mask. You can change, of course, everything. So here we now have a maximum for Italy in the ERA5 surface temperature for the year 23 from August all days. And when I click start here, I hope you can see my screen. Can you see the Stat-on-Edge window? Otherwise, I need to shift that.
I think you need to shift. It's
okay.
Masked out.
Yeah, thank you very much. So here we are, and I hope you can see it now. Great. So what you see now is in real time, it grabs the data, brings it into your browser, cuts the boundary out of Italy from the data, calculates the mean, and plots it here, plotted here for these months and for these days in the months of August in the year 23, and then it's done already. You could download it and you could work further with that. So I just need to switch back here. Oh, wait a second. Here we are. I hope you can see now the browser from before. Great. Now, here you have the possibility to go down, much further down. So we have included for Europe NUTS even down to NUTS 3. So you know these administrative boundaries. And here you can go basically down to regions like big towns or small administrative regions within Europe. One thing which is very nice, of course, is if you're interested in very large areas, and let's head for the largest country here. Let's go for Russia, for an example. If you click here, and you do the same as before, and I hope you can see what is the imprint now. And I just switch it fast so that you can really see it. and it should work now. So it really does it in live now and does the cutting out of the whole data digital twin for these time series for the whole Russia. You see, of course, it's quite smooth curve. And this is now, for an example, the maximum for each of these days in the summer of August. Okay, so I hope that this feature is useful for you to get the first touch to the data, to get some insight, to get some feeling about the content. And but this is, of course, one capability in the service, which, of course, will be extended in the next releases, and later on Liane, our project manager for the DestinEStreamer and the DestinE Platform, will give you then, of course, more information about what you can expect in the future. Now, one thing is you can click here on the Jupyter hub, and then you can access the data in Insula and in this interactive Python environment. And here you have a couple of examples here. For an example, due to the time constraints, I just go very short through it. So you get, first of all, some information about the quality assessment. Then you can connect to the data. Then you need to load our modules to interact with the platform, with the service. Then you can give some parameters for which data set you want to access, for which time frame you want to access. And a nice feature we have here, for an example, if I go back to the DestinEStreamer, you have here access data in the platform. When you click on that, a pop-up will appear giving you some explanation how you can access it. And for the exact date, so for the exact visual representation you have in a streamer, you get the metadata here. So you just copy and paste, or you click here, copy to clipboard. You go back to the DestinEStreamer in Insula to the notebook. Then you can insert that into the notebook, and then it will use that metadata. So here you have an example. It's Germany, and you want to have the progression of the average temperature in November 75. And then this example shows you how to access it, how to get the metadata, and how to do all the calculations. And keep in mind, if you use it in Python or here in the Insula, you have basically directly with this DestinEStreamer library here module, you have access to the data, and it will be completely deflated into your memory, and you have all the data at your hands to do further analysis with that. So have a look into DestinEStreamer in Insula, and here you have a lot of examples, and these examples should assist you and help you to use the streamer in a programmatic way, besides, of course, the visual web application, which should give you a first glance to the data. Now, I want to bring you, as one of my last points here, an outlook to what you should expect maybe this week or beginning next week. We will put an additional data set. So here, this is as shown before, it's just on a development stage at the moment. So you see here the data set, the climate data set, I showed you some of it. Here you have the Sentinel-3 data set I showed you before. And if you click on Sentinel-2, we have now the complete all the bands, the whole data. So Sentinel-2, it's an optical satellite of the Copernicus program. It has a resolution of 10 meters in optical. It has different bands, and it offers you, I think, more than 10, 12 bands roughly in different resolution depending on the spectral range. And you can access the complete data from 2019 until ongoing now and further on in the DestinE platform, and you can use it with our streaming technology there. So let's have an example. Let's go to France, and here we are in Paris. So first of all, you have the possibility to have an OpenStreetMap base layer. You can have here a static Sentinel-2 base layer. So you click on the tiling, so the data is gridded of the Sentinel-2, then you can really, you click on it, it loads the visual stream, you can fast forward it and you can see, you can zoom in, and if you find, let's say, some interesting observation, you can stop there. I just stop a little bit here. So you see here we have nearly no clouds. And now you have Sentinel-2 imagery. So what can you do now? First of all, you can download it as a GeoTIFF here. So if you click on download, voila, here we are, and you have the data on your download folder in your browser as georeferenced GeoTIFF. Or you can have download of a spectral band. So if you are interested in the 10-meter bands, then you can select the blue bands, so the blue color, the green, the red, the near infrared. And by clicking on it, it would download it as before. Then we have a special edge computing capability in there as well. And this is the spectral indices. Spectral indices are ratios of different spectral bands in Sentinel-2 or in all satellite imagery. And I have shown you before the Sentinel-3 and DVI. Same could be done here now with Sentinel-2 data. But I want to show you another one. It's the so-called differential build-up index. So it gives you an impression where are built-up areas. Therefore, I have chosen Paris, because there, of course, we have a lot of built-up areas. So you click there and you say start download. And what happens, I need to shift now to the other window as well. So it will create now the spectral index, this built-up index. So it downloads the bands and it decompresses the data, and then it calculates in the browser this index. And this is in a couple of seconds finish as my part of it. And voila, it's downloaded. And I just have a very, no, it does not work, but you can have a look at yourself then how that looks like. So it gives you basically a precise GeoTIFF where all the buildings in Paris are located in a resolution of 10 meter. Okay, so with that outlook, I want to hand over to David Kolitsus from Geo4A, and I hope it was possible for you to see how to access it and what the DestinEStreamer is all about. So thank you very much, and David, the stage is yours. I can see it, and you are muted.
I know. Yeah, now I found the button. So yeah, thank you, Wolfgang, for the technical and a nice presentation. You see my presentation, I hope?
Yes, I can see your presentation.
Perfect. Yeah, it's my pleasure to introduce Geo4A and how Geo4A is using satellite data and DestinEStreamer data to unlock insights into Earth observation and climate data. So very down-to-earth application on potatoes. So let me go to the next slide. Yeah, the vision of Geo4A is to empower efficient, sustainable potato production. So really down to earth, we want to have a well-working, future-proof potato industry. So we are not talking about potato farmers themselves, but the agri-food industry. So large corporations who have contracts with hundreds of farmers monitoring, having thousands of fields all over Europe, all over the globe, that need to be monitored. And they are under risk, under pressure due to various external factors, and they have a need for more insights and for more objective information on large scales. That's why we brought Earth observation data and climate data into this domain. We are based in the Netherlands, in Emmeloord, which is the capital of potatoes. So we are really close to our customers here. What is the potato world? What are the challenges and the opportunities that we see in the industry? So agriculture is one of the first domains that is really impacted by climate change, and especially if you're having this large corporation dealing with continental-wide field and global productions, you see the impact already. So this industry is highly impacted by climate change already, and they need to prepare for it more than some local farmers, for example. We also see rising input logistics costs, so they have overall a higher risk on the whole supply chain. So even there, spatial information is needed. So what you traditionally do is you do a lot of field monitoring. You send out people into the field, they're digging probes, so you get quality estimation on the fields. This does not work at scale. So if you expand your area of potato growth, you cannot use the same method as before. You need to find more objective, more scalable, more efficient methods. So that's why we work on with Earth observation satellite data to bring exactly in this missing information. Because why this is needed, because if you have this uncertainty, just saying field manager A here in Europe and field manager B in India, they do not have the same understanding, and they might give you their best impression, but it's not objective in the same sense. So, and this uncertainty in data leads to loss. So this is why we bring in this objective level into it. Our core product, which is called Harvik, as I said, is an abbreviation for harvest in control, because this is what this industry needs. They need to make sure that the harvest, the production is under control in terms of quality, in terms of quantity, in terms of timeliness, so that they can plan their logistics, they can plan their selling, their storage facilities, and know which potato to send to which customers, because some fields, even though they look similar, might have very different stress factors during the growing season, which we see in the climatological data and in the Earth observation data. So they're way more prone to diseases than others. So we're not only measuring the parcels, we do a full season monitoring of the field, we identify risk factors during the season, and we provide, of course, analytical functions on statistics, on regional aggregated risk patterns per crop, and also per crop variety, because there's not one potato crop, there are hundreds different of varieties, and all of them have specific risk factors that you need to know. All of this, we bring in the Earth observation and the climate data to make use of this. So our core portfolio and services is shown here. So on top of the dashboard access for all the individual feed levels, but also all the aggregated, let's say entire Europe, or different regions in Europe, aggregated statistics on what is the expected yield, what is the risk factors per field, when do we expect harvest, so that they can do the planning. So on the right-hand side, you see a sketch of the different services that we provide. So from the lower left, we start at the yield forecast, which is of course the quantity, but we also identify various phenological stages and practices in the field. The harm killing, which is a core practice to ensure quality of the potatoes. And whenever there's a little satellite, this is something where satellite data is actively bringing in information into this parameter. Of course, the harvest date, which we also think we can forecast with some uncertainty. And on top, we create individual field reports. We have very variety-specific characteristics. So as I said, one potato is not the same. We dig in from other sources like the soil type, which of course has a huge impact on growth itself. And also the emergence. So when does actually the growth of biomass start? So when the first plant leaves are sprouting out and they collect biomass in the soil. This is the start of the emergence. This is when the growth model starts to work. And of course, we also need weather data, because weather is the main driving factor for growth in the agriculture. Yeah, and all of this, at the end, we don't only want to know how much are we going to harvest, but the quality is just as important. What are the risk factors for field, for regions that we have seen during the season? What are likely diseases that might come? So what can we do to prevent this? What can we do in order to reduce claims later by other customers? And now I switch to the same slide, and I just try to highlight how is DestinEStreamer helping us. So we have a range of services that are already using DestinEStreamer for the satellite with the Sentinel data. So this is Sentinel-2 mainly driven, but we also have Sentinel-1 data, which is not covered. The weather data we're also using for calibration our services. So there we make use of the ERA5 data. DestinE in a sense is very helpful for us to have these services in the same platform, because as you said, our customers are operating all over Europe, and we don't want to have weather data from different providers for different areas. Otherwise, we would not have this objective information at scale. And as you can also see, we're also planning to include various new services. And mostly this is climate-related services. So our customers not only want to know what do this happen in this season, they're also questioning what is happening in 10 years and 15 years from now. Are the fields we are growing right now, are they still suitable in 10 years? So first level that we give them is like the numbers of expected heat days. How much will they increase over the next 10 to 15 years? So they can make initial estimations. Is this still a sustainable growth, or do they need to move somewhere else? And they are already moving. Or do they need to invest into irrigation? So there are different ways to mitigate, to adapt to climate change, and they need objective information on this. And on my last slide, I'll just give a summary. So yeah, DestinEStreamer is one technology that we are using to have data access in a streamed and timely manner. And we have two use cases. One is the in-season monitoring, where our services rely on timely, accurate Earth observation and meteorological data. There it helps to have everything in one place with the European coverage or global coverage. And what we do with it for our customers and translate it into growing insights for the season and quality assessment in season for decision-making during the season. And the second one, which is the strategic planning, this is where we are working on, is integrating the latest climate data, which is also available within DestinE, which is, of course, where are cultivation areas moving? What is the risk of failure? What do we need to do in sense of adapting to this? Do we need to change? Do we need new varieties? Or do we need maybe really to go to other places? So this is like what they're looking for is like 10 to 15 years planning. And just to give an example, the potato seed industry, they have a typical planning of like 10 years. So this is their time frame that they work on. And by this, I think we are pretty much on time. I thank you for your time, and yeah, happy to answer any questions, I guess later, or you can contact me via email if needed. And I think I will hand over to Lian for the last presentation.
Yes, thank you so much, David. Let me also share my screen. Let's see, I hope that it works. There we go. Are we seeing my screen? Excellent. So hi everyone. Yeah, Wolfgang already shortly introduced me. I'm the project manager at GeoVille, responsible for all upcoming DestinEStreamer developments. And I'm happy to give you a short overview into our DestinEStreamer roadmap. So last week we've already just released a new data and visual streams with the Sentinel-3 NDVI index on a global level, which was demonstrated nicely by Wolfgang. Then next, this is upcoming in this week or perhaps next week, depending on the end-to-end tests that are currently running. We'll be releasing the Sentinel-2 streams showing optical data for Europe, which can be streamed per tile, which was also nicely demonstrated already during this webinar by Wolfgang. Then next, our in-browser statistical analysis tool StatOnEdge will be extended to include other indices for climate data streams. So this will be digital twins, RF5 land, and later in January we will also include Sentinel-3 and DVI into our StatOnEdge tool. Then we're also happy to introduce two new features. One will make it possible for users to select an area of interest instead of being bound by predefined administrative, regional, or national borders for a StatOnEdge tool. And we will introduce a snapshot feature for users so that they can easily share watermarked visual content from our DestinEStreamer, so they can use this on other platforms or on social media, because it's also very appealing and attractive content in that sense, and can be very highlighting and visual in that regard. So it's nice that it needs to easily be shared. Then we would like to shortly mention, last but not least, that we are developing a brand new service for the DestinE platform that further builds off of the data access capabilities of the DestinEStreamer. This service will be a cloud-based content delivery network that optimizes data access and distribution, ensuring low latency and scalability for users. And users will then be the other service providers that are operating on the DestinEStreamer, on the DestinE platform. And we aim to prove operability by the end of the summer next year, and from there on start preparing for actual release into production. So that will be it from my side. Thank you very much, and I think we are ready to move on to the Q&A. And I will stop sharing.
Thank you a lot for these presentations and these insights that you shared and the demo. So now if anyone has any questions, please write them either in the chat or in the Q&A box that you should find at the bottom of your screen. And as shared before, so we will try to answer some questions here. If you have any remaining questions, we will also include it in a Q&A document that will be shared afterwards on the Learning Hub. And we will also share with you the recording afterwards. But please, if you have any questions here, I see one question from Janina, which I think is regarding
yes, I was actually typing in, but it's quicker if I reply live. There are certain categories eligible for upgraded access, and the process is entirely managed by the European Commission. So private email addresses are not accepted, and unfortunately there's not much that we can do to help you, Janina, unless you get into like a research institution. At this stage, these are the rules. So this is the answer.
Thank you, Barbara. I think we have one question that was actually shared on LinkedIn. I think it's for David Kolitsus. So from your experience in agriculture and Earth observation data, do you think DestinEStreamer could evolve towards a cloud-native model similar to, I think, NASA National Aeronautics and Space Administration Earth data, so where users can process and analyze information directly in the cloud?
Yeah, thank you for the question. I've seen it. I did not reply yet on LinkedIn because I would also need to have some technical exchange. So I will hand over to Wolfgang for the answering this. But I think the short answer is
sure.
No, it's quite different. But Wolfgang, please elaborate on that.
Okay, thank you, David. So first of all, the DestinEStreamer is of course increases the capabilities of the DestinE platform. So the DestinE platform itself offers services to compute, to analyze the data, to work with the data. So I hope you have a look then at the platform in detail, how it can serve your needs. On the other side, the DestinEStreamer has a special focus due to the compressed data to use the data at the edge as well. So to include the capabilities of your device for small analytical or even intermediate analytical investigations within the platform ecosystem, meaning by using our web application. And in the web application, there are so-called WebAssembly modules which connect to the streams, get the data to your browser, do all the analysis there, and then displays you the result or gives you access to some download access.
Thank you a lot, Wolfgang, for answering this. I see there is one hand raised from Seima Bayram. Would you like to actually write in the chat, or I can actually also allow you to turn your microphone on if you prefer to speak? Seima? Let us know if that hand was raised for a question or not. In the meantime, I think there was another question regarding, again, DestinEStreamer. So if you can elaborate maybe more on how it lowers technical barriers for users who may not be data experts.
Mm-hmm. Okay, so I think the most important thing is that you have two vectors to use the data. As an expert, you can use it within your analytics in Python. You can have access typically we use Python here, and we offer here Python modules, but you can access it in all other languages where there is a binding for our streams. We have solutions for Rust upcoming. And you can then do all the expert analysis. But of course, if you are a non-expert and you want to get some insights, what kind of data is offered in the DestinE platform, I think it's a very useful starting point. Why? Because you have these visual streams. You can have a look at the data. You can look it on the globe. You can look it in your region, and you can even get some basic statistics as I have shown in this Start on Edge, where you can have a look in your NUTS region, so into your administrational region, into your city, if it's a large city. And in the upcoming releases, as said by Liane, there will be, of course, the possibility that you draw your own polygon, that you have more interactive features in the viewer to grab more, to get more insight into the data. The point is that you do not need to be an expert for that access vector. Why? Because you have the user interface, and you do not need to understand completely the structure of how the data is stored in the platform. The data could be in original format stored in gridded binaries, in tar files, in all different kinds of formats. You, as a non-expert, should not be bothered by any of these obstacles. You should intuitively interact within the web application and get your insights. So by these two vectors, we hope to offer you really a useful service when it comes to handling data.
All right, thank you a lot. Thank you, Wolfgang. And we have one more question from the chat. So that's regarding data analysis. So is it done on the compressed data or on the original data?
It's on the original data. So that means on the decompressed data, to be very precise. So the compressed data is transferred to your device, in Insula, for an example, into your Python environment. And then our library does all the decompression as described in the documentation, or very shortly shown before in the example. And then it will be deflated into your memory, and then you're basically free. It's an array. Do whatever you want. It's of course a geo-referenced array with the timestamp and all the metadata included. And by doing so, by offering this access, you can then work further. The nice thing is it is very fast. So if you would grab to the non-compressed data and you would try to draw, for an example, over years, some mean temperatures for large regions like, I don't know, Africa, then it is then the DestinEStreamer is ideal for you, because you can really access very fast the data in time and space.
Thank you a lot for answering this. And I think we are almost at the end. So if you have any other questions, please write them right now in the chat or Q&A. Otherwise, I think we'll be starting to close the session, the webinar. And I would also invite you to actually share your feedback and your views of how was this webinar for you, and if you would like to obtain more information. So I'm sharing with you right now the link in the chat for the feedback form, but also we will share it with you afterwards together with the recording via email. And so please, it's anonymous, so please feel free to express your opinion there. And with this, I would like to first of all thank all the panelists today for your time, your availability, and this discussion about the DestinEStreamer, DestinE Platform, and all the features of DestinEStreamers in this insightful demo that you made for us today. And also thank you to all the participants who joined today, and we hope it was very useful for you. And if you want to learn more about DestinE Platform, please feel free to go to the link that we shared in the chat to obtain more information about it. So again, thank you a lot, everybody. and have a nice day.
Thank you. Bye.
Thank you so much, everyone. Bye.